Fine. So in the previous class we have seen when we apply deforming force, there are some materials which regains their shape and size. That type of materials are called as the elastic materials. So that will happen due to some restoring forces will develop inside the material. We have seen the explanation in the molecular level. Let us define what is a stress and what is a strain. Let's see. So I have defined first stress. It is sigma. So it is defined as restoring force per unit area. Restoring force per unit area. Okay. So sigma will be is equal to restoring force divided by area. So obviously what is the SI unit will be? SI unit of sigma will be, force is of Newton, area will be of meter square. Okay, Newton meter per minus 2. Newton meter power minus 2, or you can write Newton as kilogram meter per second square also. Okay, fine. Now let us see this. I have the situation, even define the stress also. Stress. Let's say I have the situation, there is a rod, there is some material will be like this. Let's say I will apply some force will be in this direction. Even another force will be in this direction, such that the net force will be 0 and the object will be at rest. Even the object is at rest, but there is still tension inside the material. Restoring force will be there. So let's say at this cross section or at this particular point, at this point, so whenever I am pulling like this, there is some internal forces will be there definitely. So there is some internal forces will be developed. That internal forces we call as the restoring forces. That restoring force per unit area we are calling. It is not the deforming force, it is restoring force per unit area. So okay na? So this is what like this. Okay. So in some situations there may be a force which is acting some angle. Okay. So that time what happens? So let's say there is in the same problem. Let's say this is the problem. Yeah. There may be a situation will be like this. Let's say this is the situation. So this is the surface, but a force will be acting in this direction. The deforming force will be acting in this direction. I can break up into two components. One parallel to the plane, another one is normal to the plane. Okay. This we call as the parallel to the plane, and that is generally we call as the tangential component. And this we call as the normal component. So if this type of is there, we call as the tangential stress. Okay, if this is there, normal stress. Okay, so tangential stress ne even shear ani kuda antaru. It is ila parallel to this end. So tangential stress or otherwise shear stress. So tangent, and this is the normal. Okay, fine. So మనం జాగ్రత్తగా డిఫైన్ చేసుకోవాలి అక్కడ. సో ఇట్ ఈస్ ద డిఫార్మింగ్ ఫోర్స్. వీ నీడ్ టు టాక్ అబౌట్ ద లోపల ఉన్నటువంటి రీస్టోరింగ్ ఫోర్సెస్ గురించి మాట్లాడాలి. వీ నీడ్ టు టాక్ అబౌట్ ద రీస్టోరింగ్ ఫోర్సెస్ విచ్ ఈస్ డెవలప్డ్ ఇన్ సైడ్. దట్ రీస్టోరింగ్ ఫోర్స్ పర్ యూనిట్ ఏరియా వీ డిఫైన్ యాజ్ ద స్ట్రెస్. నౌ లెట్ us define what is a strain. We'll define strain. So whenever there is a deforming force, what will happen? definitely the object will be deformed. There may be a change in the size or there may be a change in the shape. So stress is defined as restoring force per unit area. Strain is defined as changes divided by original dimension. Change in dimension divided by original dimension. So change in dimension divided by original dimension. Change divided by original dimension. For example, I'll take like this. So you take the same situation. I'm taking a rod, a wire or otherwise, one dimensional object, and I'm applying a force will be in like this. So ఎలా అప్లై చేస్తున్నాం ఫోర్స్ నార్మల్గా అప్లై చేస్తున్నామా టాంజెన్షియల్గా అప్లై చేస్తున్నామా వీఆర్ అప్లైయింగ్ నార్మల్ టు ద సర్ఫేస్. Then what happens here? The length will be increased. Let's say length will be L. After deforming force, then the situation will become like this, F and F. Let's say length is increased L plus dl. Okay. So we call as this is the normal stress is applied here. The deforming force is normal to the surfaces. So normal restoring forces will be developed. So generally we call as it is longitudinal strain. So along the lengthwise. If there is a changes along the lengthwise, there may be a decrease in the length or maybe there may be increase in the length. Increase stretching type, decrease compressive type. So increase unte dani emantam ante tensile stress ani antam, decrease unte ganaka compressive stress ani antam. Okay. So tensile means it is increasing, tense, we are creating the tension like this. So L plus dl will be the changes. So in this case what is the strain will be? So in this case strain will be is equal to change in dimension, that is change in length, change in length divided by original dimension. So original length, so change in length delta L divided by original length will be. Okay. So as usual, what is the unit of it? What is the unit of it? As in the numerator also length and denominator is also length, no unit. So no unit and no dimension. No unit and no dimension. So no need to write the dimensions also. So but here we can write the dimensional formula. What is the dimensional formula? Force ante mass ante acceleration. So mass ki m, acceleration ki L power t minus 2. Antena? So area ki length kabatti L square. So we'll get the dimension formula here, m L power minus 1 t power minus 2. But for strain it is a dimensionless and unitless physical quantity. Okay, but it is a physical quantity. So how much strain is there? That is 1% of length is increased, 2% of length is increased. It is a measurable quantity. Okay, fine. I think it is clear. So what is the stress means? Remember here restoring force. Then students will be confused. What about the pressure? What about the pressure? So pressure ఎలా డిఫైన్ చేస్తాం? Force per unit area. That is a deforming force per unit area. Thrust per unit area pressure ante. Thrust ante external force. Antena here it is restoring force aithe RES అని పెట్టుకోండి, restoring force. So pressure is pressure at a point. Pressure at a point is defined as so thrust per unit area. Thrust per unit area. So that means thrust is the external force, that is divided by area. So of course both will have the same, unit is same, dimension is same, everything will be same, but there is a lots of difference. There it is a restoring force, that is the molecular forces developed. Okay, fine, no doubt. So now you can think of like this. Stress is also we define for the 3D cases, 1D, 2D, 3D. There may be a stress, that is restoring forces depending upon the deforming force. Deforming force may be changing in the length, may be changing in the area, may be changing in the volume. So strain There may be a strain in length, there may be a strain in the area, there may be a strain in the volume, even there may be strain in the shape. So 3 we will define. Okay, note down this.